Hello viewers, good morning. Today we are going to discuss a very interesting topic from class 10th from polynomial. Now today's topic is the relationship between the zeros of any polynomial and its coefficient. So now let us see what is it. Here we have let a general quadratic polynomial px is equals to ax square plus bx plus c. It is a general quadratic polynomial. Let its two zeros be alpha and beta. Two zeros because I told you in the previous video, if the degree is 2, then zeros will also be the same number, two zeros. Quadratic polynomial has two zeros. So first is alpha, another is beta. Then we have sum of zeros, means the zero whatever we will calculate, the total of those zeros alpha plus beta will be minus coefficient of x, that means this term, upon coefficient of x square, that is this term, or we can simply say minus b upon a. Next is the product of zeros alpha beta is equals to constant term upon coefficient of x square, that is c upon a. Now let us take an example to make it clear. So we have an example. Find the zeros of 4x square minus 3x minus 1 and verify the relationship between its zeros, that means zeros of this, and the coefficient, this term, these two terms, and this whatever. So how to do the Gaussian solution? Let px be 4x square minus 3x minus 1. So now how to find the zeros? You know, you must have studied in 9th class splitting middle term to find the factor of any of the given polynomial. So we will apply the same thing here. So x take to be multiplied, 4 ones are 4. This will be 4x square minus 4x plus x minus 1. So we take 4x common from here, we have x minus 1 plus 1 common from here, we have x minus 1. You can see these terms are same, so it will be taken outside. We get 4x plus 1 and x minus 1. Now we take them separately 0. If 4x plus 1 is equals to 0, then 4x is equals to minus 1 and x is equals to minus 1 upon 4. Say alpha. Suppose this is alpha. And if x minus 1 is equals to 0, then x is equals to 1. Say this is beta. Now verification. So just compare this, comparing 4x square minus 3x minus 1 with ax square plus bx plus c. So you can compare this given polynomial with the standard general polynomial. So here a will be 4, b will be minus 3 and c will be minus 1. So let us check how to verify this. Here a is equals to 4, b is equals to minus 3, c is equals to minus 1. Now alpha plus beta should be minus b upon a. But from the real solution we know beta is this and alpha is minus 1 upon 4. So minus 1 upon 4 and plus this 1 is equals to 4 ones are 4. So it comes 3 upon 4. So this is left hand side. Now right hand side minus b upon a. And you can see here b is 3, minus 3. So minus 3 upon a is 4. So you get 3 upon 4. Now you can see these two answers are same, hence verified. Now we have product of zeros. This is alpha into beta should be c upon a. So here also left hand side we have alpha was minus 1 upon 4 and beta we calculate 1. So it comes minus 1 upon 4. Now let us see right hand side. It is c. C you know very well, this is written minus 1. So c upon a is equals to minus 1 upon a was 4. So these two answers are same. So this is also verified. Now this is the way how to verify the relationship between the zeros and coefficient of a given polynomial by finding its zeros. Hope this is clear to you all. Now after the quadratic polynomial, we have a general cubic polynomial also, and now we'll discuss the relationship between zeros and coefficient of this also. So as we have done the earlier, let the three zeros of the general cubic polynomial be alpha, beta and gamma. You need to keep remember that in this case this a cannot be 0, because if a is 0 then this will be quadratic, not cubic. So it has three zeros, alpha, beta and gamma. So we have three relations. First is sum of zeros, so that is alpha plus beta plus gamma is equals to minus b upon a. So coefficient of x square upon coefficient of x cube and minus sign. Next is sum of product of zeros, alpha beta, beta gamma and gamma alpha. That means two zeros को multiply करना है, फिर add करना है. And cyclic order में alpha beta, beta gamma and gamma alpha. And सबके बीच में plus लगाना. There must be a sign of add between all these. Is equals to c upon a. This coefficient of x upon coefficient of x cube and without any sign, positive sign. Third is product of zeros, alpha beta gamma, that is minus d upon a, that means constant term upon this first term, that is coefficient of x cube. Now we will take an example to make it clear. Now we have a question. Find the zeros of x cube plus x square minus x minus 1 and verify the relationship between zeros and coefficient. So let px is equals to x cube plus x square minus x minus 1. So you know there is degree is 3, so it will have three zeros, alpha, beta and gamma, because we have discussed just now a cubic polynomial has three zeros. So first we need to find the zeros. So this type of question you have done in 9th standard. First we need to put some value so that the whole expression comes 0. Then we need to divide it. But this is quite simple, so I can do it directly. So I'll just make a pair here and I'll take x square common from this. So x plus 1 and minus from here x plus 1, and this x plus 1 is common, so I'll take it outside, and x square minus 1, and you can write this 1 square also. So x plus 1, and in this you can apply a plus b, a minus b. So x plus 1 and x minus 1. Now take them separately 0. So if x plus 1 is equals to 0, then x is equals to minus 1, say alpha. Similarly here also, and beta, both are same. And if x minus 1 is equals to 0, then x is equals to 1, say gamma. Say gamma. Now we need to verify the relationship between zeros and coefficient. So let us see. Now let us see the verification. So by comparing this given polynomial cubic part with the standard cubic polynomial, we get a is equals to, because nothing is equal to 1 is there, so a is equals to 1, b is equals to 1, c is equals to, because minus 1, and d is also minus 1. Now first thing is sum of zeros. So alpha plus beta plus gamma. You know here alpha beta are minus 1. So alpha is minus 1, beta is minus 1, and gamma is written here 1 third. Say gamma are written. So 1. In this left hand side we get minus 2 plus 1, so minus 1 will be there. Now come to the right hand side. So that should be minus b upon a. So b, what is b here? 1. But we need to put a minus sign. Minus. And a was 1, so this also comes minus 1. So this is verified. Both are answers same. So you can write here LHS is equals to RHS. Now we come to the second part, which is sum of product of 0. Let us verify this also once again. Now we have the second verification, sum of product of zeros, that is alpha beta plus beta gamma plus gamma alpha is equals to c upon a. So let us take the left hand side. You know very well what are the values of alpha beta. Alpha is minus 1, beta is minus 1 and gamma is 1. And ABC are already written in the previous section also we have done. So LHS will be minus 1 multiplied minus 1 plus minus 1 multiplied 1 plus 1 multiplied minus 1. So we have 1 minus 1 minus 1. So ultimately we got minus 1 because 1 will get cancelled. Now we go to the right hand side, that is c upon a. So it comes, c is already minus 1 and a is 1. So this also comes minus 1 You can see both LHS and RH are equal, so this is verified. Is equals to LHS. Both are same, so this is also verified. By the same way, we can verify the third also, which is alpha beta into gamma product of zeros, so that you can try yourself. Let us move to the next topic in the same chapter. So now to write a polynomial when its zeros are given. So let us have two zeros of quadratic polynomial, r alpha and beta. Then the quadratic polynomial px can be written as x square minus alpha plus beta. Basically this is sum of zeros, x plus alpha into beta, product of zeros. Or you can write polynomial in x is equals to x square minus sum of zeros into x plus product of zeros. So here we have an example just to make it clear. Two zeros of a polynomial are 2 and minus 3. Find the polynomial. So here we have alpha is equals to 2 and beta is equals to minus 3. Now px is equals to x square minus sum of 0, that is alpha plus beta. So you can see alpha is 2 and beta is minus 3. You can see this formula. Same thing I'm going to do. So into x plus alpha into beta. This is the formula to write some polynomial, which I have written here also. So here I have alpha is equals to 2 and beta is equals to minus 3, and alpha beta are the same thing. So it will be x square minus alpha is 2 and beta is minus 3, so it will be minus x plus 2 into minus 3. So I have x square, this will be minus 1 and minus is outside, so it will be plus x and 2 3s are 6. So this will be our required quadratic polynomial whose zeros were 2 and minus 3. Hope it is clear. Now let us take another example. Find the polynomial whose sum of zeros and product of zeros respectively are 1 upon 4 and 1. In this, actually these are not alpha beta. This is the question in your book ncert. It is question number 2, first part. So the first number is not alpha and second is not beta. Rather they have given directly. Here you can write alpha plus beta is already given 1 upon 4 and alpha beta is given 1. Now we know that px is equals to x square minus alpha plus beta x plus alpha into beta. Now you can see alpha plus beta is given already 1 upon 4. So we have therefore px is equals to x square minus 1 upon 4x and plus 1. So this may be your answer. If you want, you can take LCM also. So 4x square minus x plus 4, and you can take it 1 upon 4 outside, both the correct answers. So these are the required quadratic polynomial whose sum of zeros was first and product of 0 was second. So this second question in your book will be done with like this. Don't take them alpha and beta separately. These are not, because read the line carefully. In the line it is written the first number is being the sum and the second number being the product. I hope it is clear to you. Now let us move to another question. Now we have our next topic is division algorithm for polynomials. Let px and gx are two polynomials where gx is not 0. Then we can find qx and rx such that px is equals to gx multiplied qx plus rx. That is dividend is equals to divisor multiplied quotient plus remainder. So this is clear with this example. Let px is equals to x4 minus 3x square plus 4x plus 5 and gx is x square minus x plus 1. Now divide px by gx and verify the division algorithm. Now we come to the solution. So px divided by gx, that means x4 minus 3x square plus 4x plus 5 divided by x square minus x plus 1. So this is px and this is gx. Now we will divide here. Actually you must have learned this in 9th standard also, and in 10th also we are doing the same thing once again. So how to divide? We need to get x4 by multiplying something to this. So we'll write x square. So x square will be multiplied x4 and this is multiplied minus x cube. This is multiplied 1 plus x square, and I'll subtract. So sign will be changed. Now you can see there is nowhere anywhere x cube term. So we will write first this x cube here. Then this is 3x square minus and one more x square, so minus 4x square, and this 4x, and finally this 5. Now we need to get this number from this. So this is all positive and this is also positive. So we'll multiply it by plus x. So I get x cube, x with the x minus x square, and x with 1 plus x. Again I will put a subtract. Sign will be changed. So now x will get cancelled, and 4x square minus and x square plus. So it will be minus 3 x square, and it will be 4 plus and minus, it will be plus 3x, and finally 5. Now I need to get minus 3. X square is already there, so I'll write minus 3. Minus 3 x square, फिर माइनस 3 को इससे करेंगे मल्टीप्लाई, तो माइनस 1 प्लस हो जाएगा 3x, एंड फाइनली इसको इससे करेंगे तो माइनस का 3 हो जाएगा. फिर से हम साइन चेंज करेंगे तो ये नंबर पूरा कैंसिल हुआ, एंड दिस आल्सो कैंसिल. बस यहाँ पर आपको 8 बचेगा. You know very well, this is called the remainder. This term is qx. This is what? Qx quotient, and this is rx. This is equals to 8. Now let us verify division algorithm verification. How to verify? So px is equals to, let us check what comes. Gx was x square minus x plus 1, and qx is x square plus x minus 3, and rx is plus 8. Now you can multiply the brackets. So x into x, x4, x into x minus x cube, x into 1 plus x square. Now x into x plus x cube, x into x minus x square, x into 1 x, then minus 3x square, 3 with x plus 3x, 3 with 1 minus 3, and finally this plus 8. Now let us check what comes here. So x4 is alone term, x cube is here, and x cube plus is somewhere cancelled. Now x square get cancelled, so I get minus 3x square, 3x here and 1x is there, so this is 4x, and minus 3 plus 8, so it is 5 plus. You can verify this and this number are same, so division algorithm is verified. Hope this is clear. For the next questions, we will meet in the new video, and just go through the video, and if you find it useful, helpful, then press like and subscribe my channel for the more videos of your class. Good luck. Have a good day.